Right. More minesweeper. Today we are actually listening to the official live stream. Well, not official, the main live stream from Lo-Fi Girl. Got the actual Lo-Fi playing. It's pretty late at night, so I'm playing this to calm myself. So yeah, we still have 9 more puzzles to go for the 6+ gallery. So we'll try and work through them. And then when we get to 28, we'll get the achievement, hopefully. Okay, so connected lyre. Just by coding, and you can get anything right now. You can get that. Okay, sure. Okay. 1-1, 2 partition, 0-3 cross. 2 partition. 0-3 cross is interesting because if it were telling the truth, then the 2p is lying. What that is to say is that either one of these are lying, so these are all empty. So these are all telling the truth. So 0 modulo, 0-2 mod is interesting. 0 mod 3 is 3, because it can't be a 0. So there must be 3 mines around this. Oh, I like green on this palette. Green on this palette actually has a very distinct marking, so you can see it very well. Okay. This 4 could be a 3 or a 4. It can't be any higher. This 5, I guess, could also be a 4 or a 5. It could be a 4 and then this could be a liar. Or it can be a 4 and this could be a 5. That's true. No idea. Okay, this can never exit out this way. Because in exiting out this way, you would reach a... This would have to see 3 mines. And 3 mines is 0 mod 3, which this 2 can never be even if it were line. So because this set of mines can't leave here, it has to leave through here. So these are both mines? Oh, it can also leave through here. Okay. Well, yeah, that makes sense. I guess it does. So there are still 2 exits. It's either here or here. Can I prove that this exit is wrong? Oh, no, that was part of the music. I heard dialogue and I thought like I was watching an ad there for a second, but no, there's the music. Cool. I mean, in this case, yeah, actually, because mines can't go this way, there's essentially a very long wall that exists, meaning that there can't really be an exit this way either. This is forced, which I think is crazy, but okay, fair enough. 3 modulo. Well, you can't have a mine here, because these both being empty would form a wall, which blocks your connection. Okay, and now I can see that rows 2, 3, and 5 form a triple, where these 3 rows occupy these cells here, each of which contain 1 mine. In the 3 columns, there are also 3 total layers, which are occupied by the 3 layers in these 3 lines. So nothing else layers in those 3 rows, columns, and in particular, this is therefore a layer. That's great. That's actually like the very first time in a long while I've ever had to use that trick. That might not even have been the intended trick, but yeah. I can see that wherever you put a mine here for this 3, you add 1 to the count of this 5, which is either a 6 or a 4. So by adding 1 here... okay, by adding 1 mine here, this 5 already sees 5 mines. The 4 it currently sees plus wherever there's 1. So this 5 can't see 4 mines as an area, as you see 6 mines. Can I? There. And so it has to grow. That's a mine. It has to grow and exactly stop at 6, so that's empty. You can exit out here, I believe. Oh, also this is empty now, of course. So that gives the liars here and here. This 4 is therefore just a 3, so that's empty. That's a mine. 1 deviation is lying, so it's 0. That's also empty by the connected rule. Okay. 3 deviation is telling the truth. Okay, so that means that 0-3 cross is also telling the truth because they share the same region and they have the same value. This 0-3, if it were lying, must not sum to 3. So this has to be telling the truth. That's a lie. This is telling the truth, so that's a mine, and then one of these are mines. 0-3 telling the truth is easy. So everything else is a mine. Nice. Cool. Great start, great start. Okay. I wanna pop open a drink. And by drink, I mean green tea, non-alcoholic. Also not like actually freshly prepared green tea. Bottled green tea. It's good stuff. There you go. Can you hear it? I don't know if you can hear it. I don't think you can. I love the fact that I can do this random nonsense while playing this game, because I'm not actually officially recording this for like a series. This is so cool. And like I can just chill. I was thinking about doing this while on Discord call. The problem with that is obviously if anyone else is in there, they basically have to consent to being recorded, and I'm not super bothered to ask, so I might as well just don't join any Discord calls while I'm in here. Yeah, let's see who's on Discord, by the way. I feel like no one's on Discord right now. In case you didn't know, it is 3 a.m. where I am. In America, that would actually be in the middle of the day, like 2 p.m. I think, or 4 p.m. I forget. Actually, let me think about it. I know America is 11 hours behind where I am, so it'll be 4 p.m. Yeah, it's 4 p.m. the previous day. All right, triplet encrypted. Okay, so one triplet means mines cannot form rows of 3, orthogonally or diagonally. So either B is 5 or D is 5. Okay. I think B and D being 5 both have some consequences. For example, B being 5 requires those to be mines because you can only have a maximum of 2 here. That actually breaks because these are both empty as well by triplet, and B cannot be 5. So D is 5. Okay. Well, you can only have a maximum of 2 mines here and 2 mines here. So this is always a mine. Now you can only have 1 mine here at most. And then you could have 3 mines here, you could have 4 here. I don't think it really matters. But we know A is at least 1. A also can't be 4, because then you'd have a very obvious row of 3. So now either B is 4 or E is 4. If E was 4, that would be quite interesting. But nothing would be broken, I think. B would have to be 3 actually. And then C would be 1 or 0. Doesn't really matter at that point. So if B is... if E is 4, B is 3. You get this setup. If B is 4... I think that also calls for some very interesting things to happen. It's a bit like 5, but slightly less restrained. I think that might change things up quite a bit. That might make things a bit more relaxed, though. Yeah. Okay, let me think about it. If these 3 are mines, you get this to happen, which looks pretty good. If either of these were empty, then this would be a mine. The other one will have to be a mine as well. And you get this setup. That's your other option. And obviously you can flip that to get something like this. It seems like No, this can be empty. You can have mine here, here, and then 2 mines here. That was a horrible looking 2, but yeah, it's possible. For B to be 4. Okay. Not quite sure what really happens here then. I think if B was 4, you could literally have any combination of mines that would technically work. Like anything could be empty, and you could still make things work out. Like this. If this were empty, you literally do the exact same thing. If this is empty, then you could do this. And if this is empty, you could do the same thing. If this is empty, you can just flip whatever we said in the beginning. So yeah, when B is 4, anything can happen. I feel like the fact that either B is 4 or E is 4 is quite interesting as well. I don't know. Can B be 0? I feel like B can definitely be 0. Well, no, because there must be something here, otherwise the 5 vanilla would fail. B isn't 0. A could actually just be 1, straight up. Actually, A can't be 1. If A is 1, then the 5 here would force this A to be a 2. A is 2 or 3. If A is 3, then this is a mine. You can only have 2 mines here, so these are mines. This is empty. These are mines. And then this is a mine for the A as a value of 3. It's not bad if A is 3. If A is like another value like 2. Well, I don't know. If this is empty, then this is a mine. I don't think this can be a mine, because then these are both empty when A is 3 and that fails. A is at least 2, so that's also a mine. This can happen. I think the 5 is now broken, right? Yeah, the 5 is definitely broken. Okay, so if this is empty, that fails, so this is a mine. It's kind of horrible. I guess we can now eliminate this being a mine, because A being 3 forces that due to this, and then this A is broken, so this can't be a mine. Okay, B is now at least 2, that's great. In fact, because at least one of these are mines, B is at least 3. Okay. We also know this is a mine. Because if it isn't, then this 5 vanilla is broken. In fact, because there's some number of mines here, B is 2, 3. If B is 3, A is 2. This is empty. Mine, mine, empty, empty. Seems okay. If B is 4, this is a mine. Because you can't have both of these be mines, I guess. I don't think this quite does anything. Anything can happen after this point, I think. Yeah, A being 3 is fine. A being 3 forces B to be 4, it's whatever. Like this does something, but I can't quite tell what. Yeah, whatever is here straight up just decides whether A or is a 2 or a 3, but nothing. I don't know. Can E be 0? I think there's a good chance that E can be 0 as well. Because E is negation, and like literally anything can happen about negation. Oh my god, yeah, I never clicked this before. I was wondering how you could tell what each rule meant. Because like once you leave the clue, it doesn't. Yeah, but clicking hashtag lets you see every rule. Oh my goodness, look at this. Wow, I never seen this before. In hashtag in the first game, it used to be just a pop-up window here. I like the pop-up window. It's very convenient. Anyway. Okay. don't know what this is about. Yeah, I don't know what this is about. It's possible for A to be 2 and B to be 4, I think. You'd have something that looks like this. I mean, I kind of already mentioned that, I guess. I think that fails though, because like C and F now have to be 1 and 2. So it's really not possible for 2 and 4 to be the case. Meaning either A is 3 or B is 3. That's not very useful. But okay. I feel like we should just compare states now. If it looks like this, then you get B is 3, A is 2, this is empty. Oh, actually, yeah, because they now we know differ exactly by 1, this is empty. Giving you mines here and here, that's empty. C and F are 1 and 2. So E is actually 0, which I did say was quite possible. Ended up being true. Okay. So C is now either a 1 or a 2. Not quite sure what that means. This looks like not a lot to go off of, actually. Although if C and F are 1 and 2, then A is not 2, giving us all of this. So that's a mine, that's empty. 0C means C is 2, F is 1. These are both mines. This is empty. 5 eyesight is complete, that's empty. By triplet, that's empty. 0x means these are all empty. This negation requires a mine here, that has to be empty. 1 deviation means those are empty, that's a mine. Alright, we met quite a hitch there, but that's okay. Alright, moving on. Outside liar. Okay, that gives us a mine immediately. Yeah, the square roots are always very obvious whether they're liars or not. Square roots are a liar if they have a +1 added to them, otherwise they're telling the truth. There's a mathematical proof about it, but it's not very cool. Okay, if this is telling the truth, you actually have to have a setup that looks like this for the 2 partition to work, and that just fails. The checkerboard pattern does not work with outside, so this is definitely lying. That didn't help. We know why these are mines, I guess. 5 vanilla. They could both be telling the truth. You could have like something like this, I guess. 2 product. Could be a 1 if it were lying. If it were a regular 2, you could immediately remove all of those being mines. That actually fails. This has to be lying. If it's a regular 2, it sees something root 2 away. These are both empty, and now this mine has no way to exit to reach the edge of the grid. So this is lying. These are both telling the truth, huh? This is a 5, this is a 0. This 0 must see at least 1 mine here, so it sees 3. 5 can't have these both be mine, so that's a mine. 6 is telling the truth. These can't both be mines by the checkerboard pattern. So there's only 1 mine here, all 5 are mines. All 5 remaining cells are mines. All the non-mines are connected, so this is empty. 1 telling the truth means that this is empty and one of these are mines. The other one is empty, which might be useful for this. If this was telling the truth, then yeah, whichever is empty would cause it to be complete. But it could be a 3. So this could also be empty. And then you have a mine here, which is fine. I guess if this is empty, you'd have to have a mine here. Here, I think this looks fine to me. Yeah, everything looks fine here. Alright, can I do anything else? One of these are mines. One of these are mine. One of these are liars. If this is telling the truth, then this is a mine. Then literally anything could happen here. That's fine. If this is lying, then whatever is also fine. Okay. This is a 1 product, so it needs to see at least 1 more of these. being mines, I guess. Is it possible for these to both be empty? Yeah, if this were 3, we would have a mine here, here. This 2 would have a mine here. I think that breaks. Okay, but so what? We know that there's some number of mines here, but so what? We know it's exactly 1 because it can't both be mines by checkerboard. So we know there's exactly 1 mine here. Okay. This 2 could still be telling the truth though. Mine here allows us to see exactly 2. And nothing changes. I guess now this is forced because you can't have checkerboard pattern. If it were the other way around, that would be more interesting maybe. Actually, this fails because nothing in the horizontal row is lying. So sure, I guess it has to be the other way around. I didn't like that very much. This is lying, that's a mine, this is empty. Okay, that's a liar. 2 modulo, that's lying. It's a 1 modulo. And 1 is either a 4 or... actually, I just know that these are both empty. If there were mines, then this would not allow the non-mines to be connected. This one is also empty. You could technically have a mine here and have everything else be mines, but by mine count. That's not possible. You need 6 mines to do that, which you don't have, so that's also empty. This 2 is a 1, and because it can't see 4, it's just a 1. Okay. 1, 4. Well, 1, 4 is at least a 1, 3. So this... well, it could also be a 2, 4, but that's not possible on here. Yeah, so it's this is at least a 3. So we have our liars. 3 eyesight is lying, it's only a 2. This is done, this is empty. 3 deviations done, and 1 mine remaining. Cool. Good stuff. Alright, dual encrypted. E is not 5, I mean we already knew that. EF. EF can be 1 and 2, so something is 0. If it were 1 and 2, you'd have 3 mines here. Dual is broken. Wall. I feel like if F was 0, that would make things really interesting. Then E has to be 1. Otherwise E is 0, so E is never 2, I guess. Can F be 2? I think surprisingly F can be 2. If E was 0. Can F be 0? Yeah, then E is 1, you have this. Can F be 1 and E be 0? Well, also yes, the same thing happens here. Except the F now sees 1. I feel like it has to do with this cell. This cell looks really interesting. If this happened, this F is a 2. We know E must be a 0. So you get this. Okay, that seems fine. Actually, because E is at most 1, this is always empty. There you go. These are equal values, so those are both empty. Okay, C is at most 1. Oh, in fact, C is 1, so we have E and X as well. E and F as well. Yeah, and everything basically collapses from here. This is empty, that's a mine. That completes that. 2 areas done. Okay, well, 0, 2 is... I misclicked. I meant to click the other color. Dang. Okay, so let's just do this. We know that, we know that, we know that, we know everything at this point. This. Yeah. Yeah, I should have just called it. This is empty, that's a mine. And the only place left for our last one is there. Cool, and we didn't even use any of the other letters. Very nice. Alright, Snake Liar. This is clearly empty, obviously. Can I call any of this yet? No, very good. 7 liar, 7 liar. 7 eyesight. Possibly liar. Well, this is at most a 1. Sorry, at least a 1. And whichever is a 1 would kind of block off the 7 a little bit. The 7, whichever is being covered, is at least a 6. So despite just seeing 1 here, so you need to see 1, 2, 3, 4, 5, 6. Okay. 2 wall. This mine's here. There's something here that has to go outwards because there's no other way out for that snake. So these are both mines. Okay, this being empty is bad because if this is empty, this is empty. This 7 sees way more than 7, and that's not going to work. So that's a mine. This is telling the truth. These are both equal, by the way, so they can't both be lying. They must be both telling the truth. And there are 7, so you get that. Cool. 0 partition is lying, obviously. Ooh, that's a liar, very obviously. This is a 1, by the way. That's lying. That's lying. 2 wall. Okay, well, it can't be this. It's a 1 wall, by the way, because it's lying. Because this partition causes this to happen and your snake is way too short. So it has to be the other way around. We have the dead end for one side of the snake. The other one has to be on the opposite color by parity. 2 liar is... Well, 2 liar lie is a double liar, but this is a dead end if there were any snake that went in. You can't curve around. So it's a 0. It's double line. Okay. This can't be a mine because if it was, by this it has to go in and your snake goes too short. This still can't be a mine though. 4 eyesight could be lying, could be telling the truth. If it were telling the truth, then this has to be a mine. This has to be a mine. Your mine can't go in here, and then that causes this to be a massive problem. So this is lying. Liar. Sorry, mine. Yes, snake has to go out this way and this way. Can it do this? No, because the snake is too short. And the shortest way to get the snake to be done is just by going around here. You can also prove that these are empty because they form dead ends, and the remaining mine count will solve the rest for you. Very nice. I like that, like, for snake, right? You barely have to look at the rules. And there's so few rules. It just is amazing that it works out like that. I like snakes so much. I can't stop ranting about it. Alright. We know one of these are 0. Looks like another one of those setups that we had before. Balance is 2 mines per row and column. Okay. A and F. Actually... Ooh, what in the world is this? I don't think D can be 4. Because if D was 4, E is also 4. Also, we got a pair here. C and E are 4 and 5. Sure. Either D is 3 or F is 3. Can F be 3? I think F can be 3. In fact, no. Yeah, F can definitely be 3. I don't think E can be a 4, can it? I don't know, E could be a 4. D, can D be 3? I think D can be 3. I find the idea of D being 1 is just not possible, because E is at least 4, right? What D being 1 means is that all the mines have to be 4 in the same line, and any line of 4 always results in a row of 3. So straight up D just can't be 1. Okay, that's a bit useful. I don't know, what else? Can A be 0? Maybe. Can A be 2? Maybe. I don't see how that can give me anything useful. Ooh, actually, if A is 2, this AF means F has to be 1. Mine's here, here, and here. This is 2, by the way. That's a mine. That's empty, 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 empty. Mine B is 0. That's actually fair. So I think this works out. This feels slightly like the intended solution, by the way. D is 3. E is, I don't know, like 4, I guess. 1 mine here. That kind of breaks. That kind of breaks because E is now a 3. I don't think I'm supposed to do it like this. Clearly A can't be 2 in this case, so we can eliminate that. I'll see what the hint says. Yeah, hint says that. Oh, it's by balance, of course. Every column has 2 mines. These are both mines. Okay. I was right though. A can't be 2. That was really stupid of me, by the way. Anyway, A is either 1 or 0. And actually, we know AB is 0, 1, so there's only 1 mine around it. A liar, well, it sees 2, so A is just a 1. There you go. This is empty. These are both mines by balance, which I missed. D could be 2, could be 3. I want to say it's probably... Actually, I can't tell. F is either 2 or 3. I don't know which. 0. Okay, 0 is interesting. If mine here and here, or the 0, these are all empty. Doesn't work. F is at least 2, so there are at least 3 mines around this clue. So this has to be both empty. F product. Whoa, product. Oh, that's interesting. I've barely ever seen an encrypted product clue, by the way. I can't code anything out of it. F being 3 is kind of weird in this case, I think. If you have like a mine here, you basically have to eliminate mines here, here, and here. Which breaks. In fact, okay, there's 1 mine here and there's 1 mine here. F being 3 is straight up impossible, I think. Because the furthest you can have, because of this mine by the way, is 1 mine here, 1 mine here. The furthest would be like here and here, or here and here, and both multiplied to smaller than 3. So F is just 2, I think. Yeah. Okay, 3 mines here. We know that because of this clue. Every column has 2 mines in it, so there's 1 mine here. That completes row 4. E is at least 4, so there's something here. So these are both empty. E is exactly 4, by the way. D is 3, C is 5. 0, 3 is solvable. 2 mines here by balance. Product. Could still be root 2 by root 2, I think. If it's root 2 by root 2, these are both empty. That looks fair. If it's 1 by root 2, then the root 2 spaces are empty instead. You have to have a mine here and here, and that breaks. Okay, so it's root 2 by root 2. Mine here, empty. There you go. Oh, that was really weird. I don't know if I was very happy with that solve, but sure, I'm okay with it. Alright. We've got 3 more to go. Horizontal. Are we 3 more to go? I feel like we've done that before. I guess we haven't. Horizontal liar. Horizontal liar. 4 deviation is at most a 3. 4 multiple is interesting. It has to be a liar. Because if it told the truth, it doesn't work. I can't code it this way, right? Yeah, but it has to lie. That's a mine. 4 deviation telling the truth. You can't have an empty cell here or here, because whichever is in here is isolated. So these are both mines. Additionally, this is always a group of 4 cells, so if it joined here, this would form a massive issue. And this must be a mine now for horizontal. 0, 1 is lying, so 0 area means that's empty. That's empty by horizontal. 0 modulo means those are empty. Liar here. This is a 1. So the 4 mines here, which doesn't work. This is lying and already sees 2, so that's empty. This is the 1. So there's 1 mine here, which can't be in the middle, because otherwise it has no horizontal partners. This has to see that being a mine, so this is empty, and then that's empty by horizontal. This is lying. That's empty, because it already sees 4. That's empty. This is a mine which has to grow this way. This is either 3 or 5. I don't actually know which. Ooh, 7 mines remaining. I wonder what I can do with this. This is crazy stuff. I mean, if this is a 5, you have mines here, here, and here. If this is a 3, there are a few ways you could do it. You could do this and this. You could do this, and this is empty. Literally, you could do nothing else from here. I feel like, yes, okay, this is really interesting. I think this only occurs in horizontal liar. You can't have mines here and here, because then they have to go outwards, and neither of these are liars. That's really cool. 3 wall is at least a 2. Actually, that's a liar. Okay. This is a 2, by the way, because it can't be a 4. That's a mine. 5x is lying, so it's a 4. By the way, there's something in here. And whatever's in here needs a partner, so these are both mines. This is complete, that's a mine. 2x is complete, that needs a partner. 2 area is done, so that's empty. 2 mines remaining means those are both mines. Ooh, very nice. Yeah, again, horizontal is like the easiest variant. I think this is the shortest layer puzzle I've ever done in this category. Connected and cryptid. So this connected is the one where you can't form non-rectangles. Okay. Typical chording, C is 5 or D is 5. D can't be 5 because you'd form a non-rectangle. C is 5. These can all be mines because non-rectangle, so that's a mine. B is at least a 1. E is at least a 2, so E is exactly 2, so that's empty. 1 is 0, so B is 1, meaning that's empty. This has to escape. D is a 3 or a 4, I have no idea which one. This means these are both mines. These can't all be mines. These 4 can't be mines, so that's a mine. Similarly, these 4 can't be mines, so that's a mine, which must do that to make a rectangle. F is either a 3 or 4. Can't be a 4, because you get this, and then 5 deviations dead. So F is 3, D is 4. This can't be a mine by connected, so that's a mine that's empty. Okay. This actually has to grow, by the way, because if it doesn't, it's actually isolated. So you get that. 1 negation means one of those are mines. 3 liars is a 4, so that's empty. That's empty by connected. 1 deviation can't have a mine here, otherwise it is isolated. 2 negation must be... Well, it can't be a 3 minus 1, because then you form a non-rectangle. So it's just a 2. That's empty. This has to be a mine, because otherwise isolate. Okay. 3 mines remaining. We know one of them's here. I guess whatever's in here needs to connect this way. So this is always a mine. Sure. This 1 deviation is done. 2 area means that's a mine. That solves it. Yay! Encrypted is also fine. Smaller grids also. Alright, the last one. Segment liar. Okay. 9 multiple is interesting. 9 multiple could be done with 6 and 3, like that. Goes to be an 8 if you were lying. 2 deviations, at least a 1. If you're a 1, well then this must be telling the truth, so that's a mine, which means this is empty. That's a mine. So I think the lesson here is that this can't be empty. This has to be empty. So this is lying, actually. That's a mine, which is connect. 0, 0 is telling the truth, so that's empty, empty. 2 partition is telling the truth, but we don't know how that works. We know that there's some number of mines here, though. Because otherwise you can't form 2 partitions. And that means for this row, these have to be empty. Okay. 1, 2. Could be telling the truth. This is at least a 2 total, which means there must be some number of mines here. So by segment, these are both empty. 2 vanilla. We know there's some number of mines here. They could both be mines, meaning all of these could be empty. 1 deviation could be lying. No idea. 9 multiple seems very suspicious. It's equivalent to a 6. In the fact that you can't have 4 plus 1, 4 times 2 plus 1. It has to be 3 times 2 plus 3. Like this, so that you can only use one of these mines. Kind of suspicious. These could all be empty, and I feel like that's really interesting. There's something here we know by segment and by this clue. I don't know. Okay, I guess we can prove that there's something here, because if these are all mines, this 2 partition is broken. So for the 4, I could be lying though. You could have something like this, right? And then these could both be empty. I don't know. Okay, let me think about this. If 4 is lying, you get these 3 being mines. So I guess how I'll mark that is X here. You get mine here, here, and here because of the 1, 2 being truthful. By default, we're telling the truth, by the way. Meaning this. You can't have 4 mines here, here, and here, and here. Sorry, here, 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 and here, because again, 2 partitions broken. You must have something here. And then, for this 1, 2, which is at least a 2, even if it were a line, also has something here. And because of segment, they must connect, so the middle point must be a mine. That's a very long-winded way of saying that I think this is always a mine. Sure, that is kind of useless. It's whatever. I mean, it helps us here, I guess. If this were an 8, I guess, that might be interesting. It can't be a 10, because a 10 requires both of these to be mines. It's either a 9 or an 8. The 9 is straightforward, you get all of these being mines. But 8 is a little less straightforward. If it was an 8, one of these are mines. Oh, well then it's still 6 and 2. So either way, 3 of these 4 are mines. And so since there's only 1 here, these are both mines. Yeah. Okay. For vanilla. I don't actually know how to... I have no idea how I'll do this. Like, these mines don't actually help me do much. It's kind of interesting that one of these are mines. Like, they're so far apart, though. All these are liars. Actually, if this is a liar, then this 1, 2 will be lying, which fails. So this has to not be a liar. Meaning that's the liar. Okay, there you go. That's empty. That's a mine by segment. That's empty by partition. This has to be lying because it can't see 5 mines. And in fact, it must see 4. There's 2 vanilla is telling us the truth. So there's exactly 1 mine here. Meaning these are both empty by segment. 1, 3. Well, this can't be a mine. Otherwise, it grows horizontally to connect. And then none of these are liars. So this is empty. 1 product is clearly lying because you need both of these to be mines for that to be satisfied. And the last 2 liars are obvious. And then we can probably chord everything to solve. Boom. No? Oh, 1 mine remaining by segment has to be this one. Hooray! There you go, we perfected the 6x6 gallery. Oh, that is satisfying. Let's see if we can go update my tracker about it. My tracker is like a little small elfish guy who like runs up to me and is very excited to hear about the news I have. Hey little elf, I've completed 28 what am I saying? I've completed all the puzzles in the 6x6 plus gallery. And then the elf will throw up its hands in amazement and like applaud for me or something. I don't know. Hooray! You did it! Alright, I mean I could do more. I kinda am in the mood to do a bit more puzzling. I don't think I'll work on the 7x7s yet, the 7 plus yet. It would be quite cool to do the 7 plus right now. I actually don't mind. My other plan was just to do this. So like really. What's the difference, right? I guess we'll start working on the 7 plus gallery. Sure. So we'll start with this one. We need to finish 49 of each side. Also, I'm missing one here, by the way. Apparently, I cleared one without perfecting it. I don't know where it is, but it's okay. All right. I guess we'll start solving. Outside product. Okay. Well, this can't be root 2 by root 2 because you'd have to have mines here and here, and that clearly breaks this one. So it's 1 by 2, meaning these are both empty. And if it's 1, then this 2 must be root 2 by root 2, so that's empty. And there must be at least 1 mine here, which completes this root 2, so that's empty. This root 2 also needs a root 2, which means this root 2 will be done. And that's it. Okay. There could be mines here and here, which allow these to both be empty. This root 2 must have something here though, at least one. Ooh, this 4 is interesting, I think. This can't be a mine. If it was, it would be completely isolated. It would have to be like a root 2 by, I think 2 root 2? Yeah, to get 4, and the closest one is this one, so everything closer is not a mine. Sure. So this 4 is either 2 by 2, which works. This 2 would be a root 2 by root 2. Or it's a 1 by 4, which I think doesn't work. Because if this happened, not only would all of these be non-mines, all of the mines that were root 10 away are also non-mines because root 10 is less than 4. And that just breaks this 2. So none of these are mines. This is interesting. This can't be root 2 by root 2, so it's 1 by 2. This is root 2 by root 2, so that's empty. This is 2 by 2, so that's a mine. This must have a mine there. These are both empty by this one. This is a mine. And then for the second time, we use the outside rule. This can't be a mine by the checkerboard pattern. These are both mines by this one, and that's a mine by checkerboard pattern, so that's empty. Ooh, 2 root 2. Okay. Well, if this is a mine, this must be empty by 2 root 2, which doesn't work because it can't escape. So this is empty. That's a mine. This root 2 must have a 1 next to it. So this is root 2 times 2. These are all empty. This is a mine. This is a mine, and also that. This can still be a mine, because these can all be mines to fill up the space. We have enough. We know these are both empty, though, by this root 2. And then that's a mine, which means that's a mine, because no checkerboard. Okay. Ooh. I don't think these can both be mines. Because if they were both mines, by checkerboard, this also has to be a mine. And then you'd create this wall. So these can't both be mines. So for that to be at least 2 mines for this one, this has to be a mine. Can this be a mine? It looks like it can. Oh, but this can't be a mine because, again, the wall. Okay, there's at least 1 mine here for the 1, which would complete this route 2. Okay, that solves a bunch of stuff. Okay, 2 mines remaining means this can't be a mine. Because, again, we said we could fill up the space here, but not anymore. So this can't be a mine. Similarly, this can't be a mine because you have to fill up, you use 3 cells. This is empty, and therefore these are both mines. Ooh, I like that. It's very nice. Alright, continue. Encrypted dual. I feel like we've done this before on the hashtag grid. Ooh, triple A. Okay, a bit more. We have a triple here. B, C, and D are 4, 5, and 6. Nothing is 4, except B, C, and D. Can D even be 4? Yes. Can G be 4? Well, it isn't. Okay. D can't be 5. Because if D was 5, yeah. So D is 4. Which is interesting. These can't all be mines. So this is a mine. Which must grow. Also, you can't have an empty cell on the edge. Because you'd have 3 mines together. So these are both mines. This is empty. A is at least 2. This is empty. G can't be 3 anymore. If E is 3, A is also 3, so E can't be 3. If A is 2, I guess E could be 1. E has to be 1. Ooh, but if A is 2, forcing E to be 1, that breaks, because you have a lone mine. So A is 3, meaning that's a mine, that's a mine. E is now at most 2, which it is. That's empty. 3 means 1 mine here, which will pair up with this to form your dual, so that's empty. Okay, so F and G are at most 1. We can use that to mean that, to say that these is not a mine, otherwise it has to extend. Same for this cell here. In fact, the same works for this cell here. If this is a mine, then it has to go this way, which doesn't work. Now we know F is 1. Okay. G is 0. This has to grow. This has to grow. This is empty. This is empty. 4. Wow. Okay. I know this can't be empty, because if it was empty, then this is also empty. The 4 must be fulfilled like that, and that breaks dual. So this is a mine. Okay. Alright, I see a few ways this could be done, but there's some commonalities. This is a mine, causing this, or if I could just scroll, my fingers are not doing very well. Or if this grew this way instead, then this is also a mine, so the commonality is this and this. So now these are both empty. This now has to be empty. So that solves that. 2 mines remaining. Those are your mines. Alright, that was fun. How many groups are there? 7. I think I don't know how many mines are in 8x8. I can go and check. Really quick. 10. There are 10 groups. Cool. Alright, let's continue. I need to finish my drink. That was nice. Okay, these differ by 2. Like, legitimately, they differ by 2 mod 3. And in this case, they can really only differ by 2, which must be done like this. If this is a mine, does that break? Yes, these are on the same parity, which doesn't work. So it has to be the other way around. This is a 3. Again, can this happen? Same parity doesn't work, so this is a mine. In fact, I think you might have your dead ends already. If this is empty, that's a dead end. If this is a mine, you also get a dead end. But this dead end is very poorly defined, I guess. It is a dead end, but the only purpose of that is to say that there are no other dead ends, which right now isn't really a problem. I guess if this is empty, then you have a problem, because yeah, you'd have 3 dead ends. So this is a mine. Sure. Okay, this is not the same parity, so this can actually be a dead end. This is also not the same parity, so this can be a real dead end as well. This has to grow. This can't be a 7. This is just a 4. Again, no dead ends means these are all empty. 1 is just a 1. 1 is just a 1. 5 out of 6. Oh well, obviously these can't connect here because too many empty cells. So there you go. Oh, Snake is so good. I just cannot stop. I cannot stop talking about how good Snake is. This is like such an amazing variant. Oh my god. I'm sorry, I don't know like if I'm sounding kind of I don't know what I'm sounding like when I say it like that. It's just Snake is an amazing Anyway, continue. Balance area. Oh gosh, area. Yeah, look at this nonsense. Alright, in 7x7 it's 3 per row and column. So you could have some really annoying stuff. Like you could have like a what looks like a snake actually. That's a valid shape. Because it's 3 in yeah. I don't know how to start this. Well, I do know that it can't be these 3 that are mines because it breaks 2, so that's a mine. There's something here, I will say. There's something there. Because it can't both be empty. But it's... Can this be a 1? Yeah, it can be a 1. Like that. So this 2 can see 1. Which means it could require mines from here. That I don't like. I do know that because the 7 sees at most 2 here, it must see 5 when you combine these. At the very least. But that doesn't say anything about whether this grows outwards or not. I guess what could be interesting is that if this did in fact see like 2 mines like this, that almost certainly causes a problem on row 6. It's very close to causing a problem on row 6. But it's not really a problem. Can this be empty? It has to grow to a size of 5. I feel like that's possible in a very weird way. Like it breaks a bunch of stuff. But it's possible. It could see even more actually. So it doesn't have to say that this is a 2. In fact, it can't say that this is a 2. This doesn't break anything. You could have mine here. I don't know, you could have this. Yeah, like this could be all 7. Crazy looking stuff. I don't see where to continue from here. I'm gonna have to take a hint on this one. There. The number of mines in each row and column is the same. Okay. So what? If this is a mine that breaks? Why? I thought I said this was possible. Maybe this is empty, it breaks. I don't see why either. I guess if this is empty, could this ever reach a size of 5? I mean, technically yes, without going out too far. If this size of 5 goes up too far, this 7 doesn't work. It can't have a remote size of 2 here. Ah, therefore this has to be a mine. If it's empty, the maximum this can be is this. You can't go any further. Because otherwise, you either do this. This is an issue, by the way. Or you have to go out this way, which breaks column G. This is a mine. That's nonsense. It's horrible. This is also part of the 7, I think. Because again, if it wasn't, you get the exact same problem. If this is part of a 7, this can't grow down this. Oh, it can be a mine, huh? Oh. Yuck. I thought it couldn't go this way because that would break the 7, but it's entirely possible for this to grow a 7 like that. I guess. If this is a mine, this can always be a size of 6, and then this can, yeah, I don't know. Where should I go from here? There. Okay. So if this is a mine, anything break? Okay, well these can't both be mines. This is a mine. This now can't be a mine. That's a mine. And now wherever this grows, you'd have this which breaks or this which breaks, which so this can't be a mine. That's so annoying. Now this is a mine, definitely. If this is a mine, these are both empty, and that breaks because this breaks this too, so this can't be a mine now. I think the 3 having a mine here is what allowed that to be a deduction. Alright, so this is at least a 2, I think, because the 6 here seeing 1 mine means that there's at most 5 seen by this area. I feel like you can do a lot more than just that, because this doesn't just see 5, it sees a lot less. This has to grow. No? Oh, is it because it can do this and see that? Yeah, I guess that's why. Okay. This is a mine, definitely. Because again, these can't both be mines. Okay. If this is a mine, this is empty. Don't see how that works. If this is empty... If this is a mine, empty, empty. I'm kind of just grasping at straws here. Again, I don't know. Can these both be mines? I don't think so, right? Because this 6 would see like a bunch of stuff. Yeah. There has to be a break in here somewhere. But I guess you could have something like this. It looks valid. So either you have this, and then actually that breaks. If this happened, this needs to see a size of 6, and then it has to grow all the way up here. So it has to be the other way around, like that. So this is a size of 5, which has to go upwards. This 6 seeing 5 here and 1 here is done. So those are everything it sees. This is a size of 5. I guess I'll write that down like that. This can't be a mine then. If it is, it has to grow to join that size of 5 and break the 2 in the process. Okay, by balance, that's a mine. This is a mine that's empty. This 3 is done. One of these are mines, I guess. But this has to grow up by 1 more. This is a mine, and these are empty. 1 is done. Okay, that's a mine by balance. 4. Something tells me I need to use that 4. I don't think I can do anything else here. Oh, well, by column B, yeah, these are both mines. And this 4 sees 1, so exactly one of these are mines. If it's any more, it doesn't work. If it's any less, then the 4 is isolated. So exactly one of these are mines. So that's a mine for column C. And we know that wherever this is a mine for this area of 5, it must grow outwards. And crucially, it has to grow outwards by exactly 1. So it can't grow outwards to here, meaning that this can't be a mine. Ooh, 8. Also, I know this has to be empty now because otherwise this 4 sees 5. This 8 sees 8. And from this 1 and wherever this mine is, it would see 6. So it has to see more. This has to be a mine. These can't all be mines though. Because it would see 3, 1, and then... Well, could these both be empty? It's possible. I think there's some way this can from an area of 7. There's some way it's possible, definitely. Okay, where else? So like these could be empty, you could grow out this way and this way. I think that's possible. Or you can grow out this way, I guess. Yeah, that's also possible. If, I guess, I mean, like something like this could happen even. And that would be the craziest thing. Yeah, and then like legitimately this is a completely fine setup. I think that we have to analyze this a bit more. And prove that this is not possible. If this, then by column D, these are both mines, and that breaks, because none of these can be mines. Okay, there you go. That's how it's not possible. So there must be some collection here, meaning that this 8 sees 5 here and 1 here. It must see 2 more. And therefore, these can't all be mines. I mean, we already knew that, so that's always a mine here. Oh, I guess it's a much easier thing to say that you can't have mines here, here, and here, because that breaks this 4. So yeah, that's empty. This is to go up, so that's a mine, that's empty. In fact, by this column, that's all empty. This 8 means that's a mine, and these are both empty. That's a mine, these are both empty. That's empty. By column G, these are both mines, that's empty, that's a mine. Oh, that was horrible. But we worked through it. Okay, more. Quad cross. Okay. Well, by 1, 1, we know that there's 1 here and 1 here. This is empty. 1, 1 means there's 1 here. Okay, we don't know which. Actually, this 1, 2 implies there's exactly 1 here as well. Wow, I can't believe this is a thing we can do. Ah, I can see some very interesting stuff going on. If this is a mine, it breaks. So you have empty, empty, empty by the lines we just drew. So I guess we'll just use a different color. Mine here, empty, empty, empty. Then by the 1, 1, it forces to be a mine to balance out the colors. And by quad, this is also a mine, and that breaks this 1, 1, which now sees 2 dark mines. So this can't be a mine. That's a mine as well. We knew that by the line drawing. This, I don't know. Well, we know there's one mine here, which would be the 2 dark mines, so that's empty. And therefore there's one mine here. So for the 2-2, that's a mine. My lines are not very nice today. Oh well. Is there some quad thing that's going on here? There's some quad thing going on here. Oh no, it's just this 1-1. You can just complete it by balancing out the colors. Duh. That's a mine by quad. 1-3 means that the dark cells are the 1-3. 1 mine here, these are both empty. 1-3 is done. 2-2 means 1 mine here, 1 mine there. 2-2 here actually is done. So that's done. That's empty. 1 mine here. 3 means 1 mine here. This is empty. Oh my god. 1-3 again. Could be anything this time. Okay. 1-3 here means that light cells are 3. That's empty. That's a mine by quad. That's empty. That's empty. 1-2 means light cells are 2. 1 mine here. So that's a mine. These are not. 0-2 means that's empty. Still quad shenanigans going on. Interesting. I feel like there would be some quad shenanigans by now, but we still haven't seen any yet. I feel like this 1-2 is interesting then. Can these be all empty? Yes. Yes, like that. Okay. Can these be empty? If these are empty, there's a mine there. Actually, no, there's at least 1 mine here. At least. Okay, if this 1-3 were 3 darks, then there being 1 mine here gives you this. These are both empty. Actually, that breaks. This 1-3 doing this just breaks this cell. So it has to be 3 lights and 1 dark. Okay. Oh, wait, no, this is the dark one. Oops. So this is the one that's empty. And there's 1 mine here. So for this 1-3, these are both mines. Well, there's 1 mine here by quad, and so the 1-2, which is a 3, tells me that these are both empty. Okay, that solves it. We should be able to quad like a bunch of stuff now. All these are mines. Cool. Alright, there you go. Alright, connected deviation. Connected right now doesn't require the squares. So here, literally, you could form any combination of 3. 5-3 differ by 2. There's 1 mine here. Okay. Actually, 5-3 differ by 2, and there's only 1 mine here, means that this has to be a mine, this has to be empty. Yeah. 4-3 means there's 1 mine here. That doesn't really help. Yeah, because there's two mines here, I guess. I don't think this does anything. I feel like there's a chance I want to take a look at these 2 clues. Because there's at least 2 mines here. Which might be a problem if I put a mine here, I think. Well, no. Because I can do that. Well, no, because if this is a mine, these are the ones that are empty now, and that really does form a wall. So this can't be a mine. Okay. Now there's at least 2 mines here, so for these 2 3s, these are both mines. That's a mine. There are exactly 2 mines here. There's a third mine. This has to go out somewhere, so one of these are mines completing the 3. In fact, this has to go out this way. So this is empty. This one is complete. 4... Well, these 4s differ by these regions, which must have the same number of mines. 5 is done, 2 is done, 1 can be done, 2 is done, 2 is done, 4 can be done, 4 can be done. This is one mine here. Okay, this can't be empty. Sure. Okay. I think it's interesting that there's one mine here. These can't both be empty, right? Because you form a big wall. So there's also something here. And that will complete the 4. These are both empty. This has to grow in... Well, it can grow in here as well. But if it tried to do that, would it break? Here, 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 here. I think that's fine. Like, barely fine. I don't know, it doesn't look fine, but it could be fine. Okay, let's say this is a mine and this isn't. I don't know. If this is a mine and this isn't, that does form a problem. So you get this. And then this has to enter through here. I mean, this looks fine, I will say. That is one way you could solve the problem. The other way is if this were not a mine and this was. There's still a few ways to do it. If this were the mine instead, and you can't go up this way, you have to do this. This has to be empty, this has to be a mine. This has to be a mine. I mean, that looks okay. Can these both be empty, by the way, to make this empty? And you have mines here and here. Again, the 3 works. Because you can do this. And then wow, these are mines? This is empty. I guess maybe this can't be the mine. If it's a mine, yeah, it can't grow out this way or this way. Okay, so this can't be a mine. It's not very useful. Okay, so if this is empty, mine, 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 sure, mine, sure, empty, mine, empty, mine, empty, sure. If it went out the other way, mine, mine, empty, 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 mine, empty. Aha! I feel like this always has to be a mine then. No, I was wrong. Again, yeah, there's a way for it to happen like that. I don't know what I'm doing. I think it really is time for me to go to bed. Okay, so we're just gotta keep going. Here, we know this can't be a mine. Okay, this is where everything starts. We know this has to be a mine. These are empty. We know that's empty. Okay, this is where everything happened, right? Again, so there are 3 possible ways out. Let's start with the original, where these are both empty. Then you'd have to take this route in, which you can do. Next option is if this... Okay, these can't both be mines, because these being both being empty would form the wall. So your next option is this being a mine and this not being a mine. So that will form this sort of checkerboard pattern, which is fine. That forces this to be a mine. This is not a mine. This now can't... Oh, it has to. Ah. So this group of mines now has to enter through here because this is locked off. So this is not possible. It's the other way around. It has to be this being empty and this being mines. So this will obviously give us a lot of commonalities. Okay, and that works for us. This has to go this way, empty. 2 mines remain. There you go. Okay. I'm pretty tired. I think I should stop here. I don't know how long I've been recording. More than an hour. I'd have expected that. It's almost 4:30. Wow. Alright, well, I guess that's gonna be it for this time. Next time we'll do more of this stuff. Maybe keep going down the 7 plus gallery. Yeah, until then, hope you guys enjoyed. I'll see you guys when I next do this. Alright, bye bye.